All right, let's play detective for a minute. We're about to dive into a mathematical mystery I'm calling the case of the number that doesn't fit. Our mission? To uncover a hidden world of numbers, numbers that seem to break all the rules.
It all kicks off with this one simple question. We see numbers everywhere, every single day, but do they all behave the same way? Are they all part of the same big happy family? Well, let's dive in and find out.
Okay, first, let's set the scene. Welcome to what we can call the Rational Number Club. And as you can see from this diagram, it is a very orderly place. You've got your natural numbers, like 19, tucked neatly inside the whole numbers, which are themselves inside the integers. Everything just fits together perfectly. So, what are the rules for getting into this exclusive club? Well, it's pretty straightforward, really. A number is rational if you can write it as a simple fraction, one number over another. And if you write it as a decimal, it's got to play nice. It either has to end completely, like 0.75, or it repeats in a nice, predictable pattern forever, like that 0.666 you see here. But then this number shows up. Just look at it. 0.24758326, and those three little dots, they just kind of hang there in the air, right? It doesn't look like there's any pattern, and it sure doesn't look like it's ever going to end. And this is our mystery. This number, it doesn't follow the rules of the Rational Number Club. It's an outsider, a rule breaker. So the big question is, if it doesn't fit into that neat, tidy system we just looked at, where in the world does it belong? And boom, here's our answer. It belongs to a totally different family. It's an irrational number. And an irrational number is really defined by what it's not. It's a number that you just can't pin down as a simple fraction. It completely defies that neat and tidy definition. Okay, this slide right here, it lays out the difference perfectly. On one side, you've got the rational numbers. They're predictable, you can write them as fractions, and their decimals either stop or repeat. But on the other side, you've got the irrationals. Can't be fractions, and their decimals go on forever without ever repeating. They are totally wild. So it turns out our mystery number isn't some lone wolf, right? It actually belongs to a whole family of these so-called rule breakers. So let's go ahead and meet some of the most famous members of the irrational family. Now, to really get a handle on some of the most common irrationals, we first need to talk about this idea of a perfect square. It's super simple, really. It's just an integer multiplied by itself. So, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. Those numbers, 1, 4, 9, they're perfect squares. Simple enough, right? Okay, so what happens if you take the square root of one of those perfect squares, like, say, the square root of 9? Well, you got a nice, clean integer 3. And since 3 can be written as the fraction 3 over 1, it is a card-carrying member of the Rational Number Club. No problem there. Right, but here's the twist. What happens when you try to take the square root of a number that isn't a perfect square? Take the number 3, for example. It's not on our list of perfect squares, so what kind of number do you get then? Yep, you probably guessed it. It's irrational. Because 3 isn't a perfect square, its square root can't be some nice, simple number. Nope, its decimal is going to go on forever and ever with no pattern. It's another one of our rule breakers. All right, so you've seen the evidence, you've heard the definitions. Now, it's your turn to be the detective. I'm about to show you a lineup of suspects. Time for a little challenge. See if you can spot the irrational ones. Okay, here's our lineup of suspects. We've got a whole mix here. An integer, a weird-looking decimal, a fraction, a couple of square roots. Take a second, look them over. Which ones are the irrationals? So, how'd you do? Let's break it down. That big integer? Rational. The decimal with the repeating pattern? Rational. The fraction? Definitely rational. And the square root of 16? Well, 16 is a perfect square, 4 times 4, so that's rational too. Which leaves our two culprits, the square root of 11 and the square root of 2. Because neither 11 nor 2 are perfect squares, their square roots are irrational. Case closed on those two. So there we have it. The case is closed. These rule breakers aren't actually breaking rules at all. They belong to a different system with a different set of rules. The rational and the irrational numbers, they aren't enemies. They're really just two sides of a much, much bigger picture. And this is that bigger picture.
When you put the orderly rational number club and that whole wild family of irrational numbers together, you get everything. You get the complete set of what we call the real numbers. You see, our so-called outsider wasn't really an outsider at all. It just lived in a different neighborhood of the same big city. And that leaves us with this one last kind of mind-bending thought. An irrational number, like the famous pi, has a string of digits that goes on forever and never repeats. Just think about that. That means it likely contains every possible combination of numbers you can even imagine, somewhere in that endless sequence. Your phone number, your birthday, the winning lottery numbers, they're all probably in there. So a number that seems chaotic might actually hold a kind of infinite hidden order. It solves our original case, but man, it leaves us with an even bigger mystery to think about.